In this lesson, you will learn how to graph linear inequalities. There are four directions that a line could be graphed in. It could have a positive slope where it goes up from left to right, a negative slope where it goes down from left to right, a horizontal line, or it could be vertical. So when you have the symbol less than or equal to, the first thing you want to make sure is that your line is solid. And after you figure out that the line is solid, you want to shade below. And shading below just means shading in the negative direction. The only exception to shading below is for the vertical line. And when you're shading below, it's shading in the negative direction, so on this one, it's shading to the left. So I'm going to draw the same four lines in solid because the next inequality is greater than or equal to. And now, since it's greater than or equal to, we want to shade above, or in the positive direction. So the first three we shade above, and the only exception is when we have a vertical line, and the positive direction is to the right. So for a less than symbol, I'm going to draw the same four lines, but as a dashed line. Because less than and greater than do not get solid lines. And when it's less than, we shade below on the first three, and that's the negative direction, so on the vertical it will be to the left. So with a greater than symbol, we want to shade above on the first three, and to the right for the vertical line. So when you're given an inequality and you're asked to determine whether the ordered pair is a solution, you want to think of your -1 as the x and the -4 as your y. So you take your inequality and in place of the x you substitute -1, in place of the y you substitute -4, and you determine if it's greater than -10. So 2 times -1 is -2, 3 times -4 is -12, and -2 minus 12 is -14, and since -14 is not greater than -10, it's not a solution. So -1, -4 is not a solution, which means that it would not be in the shaded region if we were to graph this. But for number 2, we take -2, substitute it in for x, 3, substitute it in for y, and in place of the x we put the -2, in place of the y we put the 3, and I get -8 minus 9 is less than or equal to 2. -8 minus 9 is -17, which is less than or equal to 2. So therefore, -2, 3 is a solution. So that means that this point would be in the shaded region if we were to graph this. For questions 3 through 8, we want to graph each linear inequality. And for number 3, we have y is greater than x plus 3. This inequality is already in slope-intercept form. So my slope is the number in front of the x, which is 1, and I want to write that over 1 so that I would be moving up 1, right 1. Graphing inequalities is just like graphing lines. My b is equal to 3, So as a point, it would be 0, 3. So when I put the points on the graph, I have 0, 3, and I move up 1, right 1. But when I connect the points, I have to connect them as a dotted line because my symbol is greater than, and greater than means that we have a dashed line and that we shade above. Unless it's a vertical line, in that case we would shade to the right. So my solution looks like this. For number 4, 2x plus 3y is greater than or equal to 6. We just have to change the form of this line so that it's in slope-intercept form. And we get 3y is greater than or equal to negative 2x plus 6. I divide all of the terms by 3. And we have y is greater than or equal to negative 2/3 x plus 2. My slope is equal to negative 2/3, which means down 2, right 3. I have an intercept of 2, so I would write that as the point 0, 2. So I go to my graph, start at the point 0, 2, and move down 2 and right 3. So since I have a greater than or equal to symbol, that means it's going to be a solid line, and I'm going to shade above. And when I connect the points, my line is solid and my shading is above. For number 5, we always start by moving the x term over to the other side by adding or subtracting, and I have negative 2y is greater than negative 3x minus 4. Now when I divide everything by y's coefficient, which is negative 2, what happens is that when you divide a negative in an inequality, the inequality switches direction. So instead of being greater than, now it's less than. Negative 3 over negative 2, the signs cancel and it's now positive 3 over positive 2. And negative 4 over negative 2 is plus 2. So now that I have it in slope-intercept form, my slope is 3 over 2, so I'll be moving up 3, right 2. My y-intercept is the point 0, 2. So my symbol is now less than. Even though originally it was greater than, I look at the direction when it's in slope-intercept form. So less than means that it's dashed and that we shade below. So I start at 0, 2, and I go up 3, right 2. I connect these points with a dashed line, and I shade below. For number 6, y minus x is less than or equal to 0. So to get this in slope-intercept form, all I have to do is add the x to the other side. And I get y is less than or equal to x. This one might seem more complicated than the others, but it's actually simpler because my slope is the number in front of x, which is 1. So I write that as over 1, so that I'll be moving up 1, right 1. And my y-intercept, since I don't have a number next to the x, it's just 0, so I'll be starting at the origin. So I start at the origin of 0, 0, and I go up 1, right 1. and with a symbol of less than or equal to, that means my line will be solid, and I'll shade below. So I connect the points and shade below. For number 7, this equation or inequality, for number 7, I'm given x plus 3 is less than negative 1. If I try to put this in slope-intercept form, I won't be able to because I don't have a y, and I have x is less than negative 4. So since I can't put this in slope-intercept form, that means that I have an x value equal to negative 4, and if I go to negative 4 on the x-axis, whenever your equation is x equals or x is less than or greater than or equal to or any of those symbols, that means you have a vertical line. And so you want to draw your vertical line with a dashed line because our symbol is less than. And less than means to shade in the negative direction, and for a vertical line, that would be to the left. And for the last problem, negative 2y is greater than negative 8. To get this in the form of y on the left, I divide by negative 2, and the rule is that when you divide an inequality by a negative symbol, the symbol changes. For number 8, negative 2y is greater than negative 8. So to get y by itself, we divide both sides by negative 2, and whenever you divide by a negative, the inequality switches direction. So we have y is less than 4. So this is in slope-intercept form, but since we don't have an x term, that means our slope is 0. And when you have a slope of 0, your line is horizontal. The y-intercept is the point 4, so we have the point 0, 4. We start at 0, 4 and draw a horizontal line. But when we draw a horizontal line, since our symbol is less than, we want the line to be dashed, and we shade below.